I'd been working on a little web API and I needed to deploy it somewhere. It's a process I've done probably hundreds of times, and there are an infuriating number of steps that always seem pretty mundane and repetitive. So rather than spend 20 minutes doing it just once more, I spent probably 10 times as long to build a tool that would do it for me. Coming up. Welcome back to Dev Parkour. In this video, I'll show you around Thing Runner, a tool I built to orchestrate and automate deployments. Why? I was frustrated that every time I spun up a silly little web app, it took what felt like an eternity to get it deployed somewhere on resources that I was already paying for, a VPS. I wanted something that was one command, no matter what I was doing, to update and start the service. And more importantly, always the same command. So whether I'm running a .NET app or a PHP app, it's always just things start and the name of the service. Furthermore, I want these services to be integrated into the system's service management, so I can do etc initd service start, or eventually launch control start service, and have the service start without having to write LSB compliant run scripts or look up launchd's configuration syntax for the umpteenth time. I also wanted the configuration to be dead simple. I still can't wrap my head around Kubernetes because I don't understand why I need 16 different files to define a single service. I also don't understand why I need a command to run locally what is really just a glorified API client, which brings me to the final piece of inspiration. I've been using Amazon's ECS a lot lately. It has a lot of good aspects, but it has two main things working against it. The first is that it's AWS. So if you don't have the requisite PhD in AWS, your chances of having the steps that worked the last time you used it work again are about as good as flipping a coin. The second thing is that it can only run OCI containers, Docker containers. This is great if everything you want to run is already in containers, but otherwise you have to add another non-trivial build step. That being said, the design philosophy around ECS is pretty snazzy. You define a service made up of one or more tasks, and you can poke at the UI or issue API calls to configure, start, stop, and update a service. So that's what I did. Basically, the process is that you install a definition and then invoke a command line tool or call API endpoints to manage the service that's defined. Start, stop, update, etc. Now, this isn't my first foray into development tools. My first attempt was a tool that I called Whiskey. The joke is that Whiskey makes every deployment go smoother. That essentially SSH'd into a remote host and reran itself with the necessary deployment configuration to install, configure, stop, and restart the app. This is actually the subject of an old video on this channel where I learned just enough Go to be dangerous. My next attempt, which I built to deploy Valence, was called Picard because of one of his catchphrases, make it so. Instead of SSHing, this one ran as a cron job on the deployment host and was configured to look for new artifacts, download, install, and configure them, and then stop the old version and start the new version. This new version had a few advantages. First, I could put the same configuration on multiple hosts, and each would automatically update itself. I didn't have to manually add each host to a CD pipeline config, so scaling up was pretty easy. Of course, we've now switched to ECS and Fargate, so scaling is even easier. Second, the production deployment configuration was separate from the code being deployed. This separation means that if I needed to change the infrastructure configuration, I could use the exact same version of code and not have to worry about rebuilding artifacts. Finally, by keeping these definitions separate, I could, in theory, set up a staging environment pretty quickly without having to modify any code or make any commits. However, one major drawback was the lag between finishing building artifacts and having them actually deploy to a server. Subsequently, there was no way to update the CI/CD pipeline to let it know the deployment had finished, especially if an unknown number of machines were deploying the code. When I eventually migrated that app to ECS and Fargate, something struck me. The final deployment step was essentially a single command that just said, go do it. All the rest of the complexity was hidden away in the task configuration. And while ECS's configuration UI definitely leaves a lot to be desired, it was still nice to be able to separate out those two concerns and version them independently. Another thing that happened around the same time was that I wanted to stick a quick proof of concept app on my VPS that has run dozens of apps over the years. Every one of the apps is unique, but many of them are basically the same from an infrastructure perspective. There are a bunch of .NET apps, a bunch of PHP apps, a handful of static sites, and a couple that I'd rather run in Docker. In fact, another tool I wrote a while back was designed to start all of the .NET apps on their appropriate ports in case the system rebooted, so Nginx could reverse proxy to them. It was a massive bash script, and it's actually still what mostly keeps those services running on that machine currently. Of course, all of these unique stacks and configurations means that I have a bunch of config strewn across the file system and no consistent way to start, stop, and especially update all these apps in a consistent way. I'd really love to have an ECS-like process to run any service that I might want to run in my VPS. As far as I can tell, nothing like this exists, or maybe I just didn't look hard enough. So I set out to build my own. First up, I wanted to build something that I could symlink from Etsy and initd as different service names, and it would automatically manage the appropriate service. This is what led to the last video on this channel, 2 videos ago. Next, I wanted something that would read a JSON formatted service definition and start one or more tasks. No more YAML. Unlike existing tools like Kubernetes, I wanted to be able to orchestrate a variety of different tools, starting with Docker and raw commands, so I could easily port over what I already had running. This led to the type field on each task definition. Of course, each type has its own configuration options. Docker needs to know what image to use, as well as optional parameters like volumes and ports, while raw commands need to know what command to run and whether to put it in the background or wait for it to exit. In the future, I'd like to add more task types like static sites, Nginx and Apache configuration, and log rotate rules. Each task also has a collection of environment variables that are passed along to whatever runs the task. Each task type has its own runner, which knows how to start, stop, update, etc. And finally, I wanted to complete the story on building something that worked like ECS and required only a single command from a CI/CD pipeline to update the service. This would require an API endpoint and also needs to be authenticated. Authentication is hard to get right, and you never want to write it yourself. However, the sort of authentication we need here is simpler than most authentication schemes that pre-built libraries would provide, and it needs to be, because these APIs are going to be used almost exclusively by other programs. It needs to be just a single token, but that means that the API should always run on HTTPS so the token isn't sniffable, and the token needs to be easily revocable in case it does get compromised. To handle this, I added a lightweight database in SQLite with Entity Framework, the API itself, and 3 new commands: serve, token new, and token revoke. Token new takes a name and gives back a cryptographically random token that is also hashed and saved in the database. Token revoke marks the token as revoked with a timestamp. Serve just starts the API. This API requires authentication for every endpoint, hashing the received token and looking for a matching record in the database. It then extensively logs that the token was used and whether it is valid or revoked. This provides an audit trail for security-minded users. If the API request is valid, it runs the requested command as a sub-process. It is highly recommended that you don't run the API as root, but that means that you also have to set up sudoers to allow the user to run the things command without requesting a password. This is the most secure way I can think to do it. More secure than running the API as root, more secure than providing a password on standard input, which would need to be stored somewhere, even encrypted, and far more secure, not to mention portable, than making the things binary set UID to always run as root. That just seemed like an absolutely terrible idea. So that's Things Runner. The code itself is available on GitHub, linked in the video description, along with a README describing how to build, install, and use it. If you find it helpful, leave a comment down below, and of course, like this video and subscribe if you're not already subscribed. Thanks for watching, and I'll see you in the next one.